Okay, so this first part on your activating strategy handout, this is day 4, so you need to have this on there, and I would suggest just copying down this table and filling in the 5 spots, 6 spots that are empty. Okay, so when you're looking at this fraction, 1/2, 1/4, 1/8, 1/16, it's being multiplied by 1/2 each time. So basically the bottom number is being multiplied by 2, because when you multiply fractions, you take the top number and multiply them together. So 1 times 1 gives you the 1. And then you take the bottom number, 2 times 2, and that gives you the 4. Now, what we're going to do here is we are going to multiply the 1/16 times 1/2 to get the next number. So if we multiply this by 1/2, the 1 on the top times the 1 gives us a 1. And then 16 times 2 is 32. So this is 1 over 32. Okay. Now here you have a 0.5 and you get a 0.25. So remember, to figure out the multiplication or the constant ratio, you can take your 0.25 and divide it by the previous number. So divide by 0.5. Now, if we multiply this or divide this, let's see, we have to move, this goes into 1, so I'm going to move this way, and so we're looking at 2.5. So 5 goes into 2.5 because if you move this decimal 1 over, that moves the decimal 1 this way, so that gives you a 2.5. So we can't go into 2, but it goes into 25 5 times. So we're multiplying by 0.5 each time. If you do the same thing with 0.125 divided by 0.25, you'd get 0.5. So I'm going to multiply this by 0.5, and that's going to give me 0.2. I forgot the number. Well, let's do that on the calculator. So we take 0.125 and multiply by 0.5, and that gives us 0.625. I don't know where I was going. 0.0625. Okay, and then we're going to take that number and multiply that by 0.5 again, and that's 0.03125. Okay, so each time here we're multiplying by 0.5. Here we multiply by 1/2. Now here you've got 50% and it goes to 25%. So you're again multiplying by 1/2 each time. So if we take 25 and we multiply by 1/2, that's the same thing as dividing by 2. That gives us 12.5%. And if we divide that in half, that gives us 6.25%. And if we divide that in half, we're looking at 3.125%. So you can see as we go through multiplying by the 1/2 to each percentage, we decrease our percentage value. So this is what you're looking at. Each time you just have to remember to find the ratio that you need. You take the number, so like 1/8, and you're going to divide it by the previous number. So in this case, that would be 1/4. And dividing by a fraction means take the top number and multiply by the reciprocal. So the 1 over 4 flips to 4 over 1, and that gives me 4/8, which is 1/2. So that's how we can create the 1/2 that we got here. And here, same thing, we took the 0.25 and divided by 0.5, and that ended up being 0.5. And here, you just take the 25% and divide it by the 50%, and that gives you the 1/2 that we multiplied by. Okay, so that's all of our activating strategy information. So that goes for day 4. That'll be turned in on the after the next one. Okay, so today we're looking at examples of exponential decay. Now we used exponential growth the last time, and that was getting larger. So these are getting smaller. Notice that all of those values that we had on our warm-up were getting smaller. So we're going to be doing stuff like that, and each of them was multiplied by a fraction or a decimal. So here it says, this is your handout, The Marvel of Medicine. These are your notes. We're going to walk through this task together. The doctor prescribed 400 milligrams of medicine to treat an infection. Each hour following the initial dose, 85% of the concentration remains in the body from the preceding hour. So complete the table showing the amount of medicine remaining after each hour, round to the nearest hundredth. Okay, so if we take 400 was our initial amount, so at 0 hours we're at 400, and then we have 85% of the concentration remaining. Now, in the equation, we want to use the decimal version, so we'll just put y. We want to use the decimal version of our value. So 85% divided by 100, because that's what percentages are out of. They're out of 100%. Those percentages are going to cancel off, and you're going to do 85 divided by 100, which is 0.85. So that's what gives us our, oops, 85. So that's what gives us our decay factor there, raised to the x. Okay, so what we can do here, if you noticed, it says 0.85. You have two of them. It's done it, multiplied it by twice, multiplied it by 3 times. So let's go in to our calculator. We're going to take the 400. We're going to multiply by 0.85. Where is it? I don't have it on this one. This is a standard calculator. There we go. I need it in the scientific. Okay, there it is. So 400, let's do the 0.85 first. 0.85 raised to the third power gives me 0.614125. I'm going to multiply that by 400. Okay, now it says round to the nearest hundredth. Hundredth is 2 decimal places. So this one here is already at 2 decimal places. So we don't have to worry about that. So we have 245.65. So we're looking at 245.65. Now I know you guys like to say 0.65, and for change that's fine, but when you're talking decimals it's 0.65 because it's not 65. It's not read the same way. Okay, so the next one, just like what we've done before, you take your previous problem, which would be all 3 of these. I don't know why they put the decimal, the little dot and the parentheses. That's kind of redundant there. Okay, and we're going to multiply by another 0.85. So that's going to be to the 4th power. So going back over here, we're going to take that previous number and multiply it by 0.85. And so 208, and this one we need to round to the second, since that one, the second number, since the third number is less than 5, that just chops off. So we're looking at 208.80. Now, a lot of times people won't put a 0 there, but since we rounded and there were more numbers, that actually is a space holder and needs to be there. So you need to keep that 0 there to say that you rounded to the second decimal place. Okay, and then we have 400, and we're going to put 5 of these. We have the original 4 from the previous problem. Oh, it takes so long to write this. And then we're going to multiply once more. And so again, going to our calculator, we're going to take the 208.80. Since we rounded it off, we're going to go back and put in that number, multiply it by 0.85, and so we get 177.48. So you can see the numbers going down, and 85% of it is less. Okay, so let's go on to the questions. So filling in the table was the first part. The second part says, what is the equation or function relationship of the situation? So like we said, I forgot the numbers that go there. So 4 was 245.65. 208.80 and 177 point something, 48. Okay, so when we're looking at this numbers, um, basically what it's asking is what's the what relationship of the situation? So what is the domain of the problem? We're seeing a starting value of 400 milligrams, and then it decreases each time, leaving 85% of what was in there before. So our domain is the x values, the number of hours. Now, this time, unlike the previous problem where it says on the hour, that's not written in our information. Okay, so that means that something's going on between the 0 hour and the 1 hour. There is actually some time, the time in there is something's going on. There's actual change in those values. So for an hour, it takes an hour for 15% of the stuff to go away. So at 1 hour, you are left with 340 milligrams. But somewhere in between there and here, 400 and 340, sometime between there and there, all those different milligrams were in your body. It was decreasing. So in this case, for our domain, we are going to start at 0, because that's our number of hours initially, and we're going to go to infinity for our domain. And then for the range, it starts at 400. Whoops, nope, sorry, that's the largest number because we're decreasing this time. So in this case, it's going to end up going to um, not negative infinity, but it's going to go somewhere close to 0. Okay, and then we had the largest number was 400. So in this case, because we're decreasing, our starting value is actually the end number of our range because it's the largest value. Remember, our range goes from um, smallest to largest. When you're looking at the interval. So you go from small to large. So 0 to 400. We'll talk about the 0 in a little bit. Okay, so here's our numbers again. How did you determine the amount of medicine? How would you determine the amount of medicine in 10 hours? Okay, so we have our equation. It was 400 times, or let's use parentheses since we have a decimal, 0.85 to the t, or to the x. Okay, so what we're going to do for 10 hours, t equals 10 hours, the time. So we're going to plug t in, the value for t into the equation. So we're looking at 400 times times 0.85 to the 10th power. Remember, this is not 0.85 times 10, this is to the 10th power. So using our calculator, let's clear everything out. We're going to do 0.85 raised to the 10th power. So that gives me this really long decimal. And then I'm going to multiply that by 400. Okay, so again, rounding off to 2 decimal places to the 100th, that's going to be 78.75. So that's 78.75 milligrams. So that would be our answer to the 10 hours. Okay, so anytime you're trying to figure out a number that's not on your list or not the next number, you can use your equation and just substitute in. So that's what we've been working towards, is getting an equation, being able to plug values in and solve that equation. Okay, now here's a question. Think about this for a minute, and Do you think the medicine will last forever in your body? Okay. Hopefully, medicine doesn't stay forever in our body. The values, as we saw, 10 gets down to, what was it, 78.75. Okay, so that's after 10 hours. So what do you think would happen after 24 hours? So if we take the 0.85, raise it to the 24, because t equals 24, and then multiply that by 400, we only have 8 milligrams, 8 point something milligrams after 24 hours. And it's just going to keep getting smaller. Now, what about, let's see, what was that? 8.09. What if we went to 48 hours, say 2 days? Okay, we're looking at less than 1 milligram. This is 0.16 milligrams. If we're looking at 48 hours, we're looking at what was that, 0.16. Okay, so we're getting really, really small here, and that's after 24 hours. So it's getting very, very small to the point where it might as well not be in our system. But here's the thing, it's never going to reach zero according to this equation. Okay, so that's what we have here. We're looking at the graph, and notice that this gets really close to that x-axis, which is where y equals 0, but that's our asymptote. That's that thing we were talking about before, the asymptote. The asymptote here, y equals 0, is something it's never going to actually reach. Okay, so mathematically, according to our equation, this is just going to get really, really small to where you're going to have lots of zeros in front. You could have like 10, 20, 30 zeros, 0.000 something, and it's never going to quite reach zero, but it might as well be because it'll be so small. So that's what an asymptote does. So as we come out here, it's going to get smaller and smaller and smaller to where it might as well be on that zero line. So that's what we wanted to look at here. Okay, so um, okay, so using your Desmos, you should have seen this graph here because you typed in this equation, and you could see that it never goes to the zero. You can actually zoom in on Desmos and see that it never quite reaches there. Okay, so let's look at another problem. Flip your work over to the back, and we're going to look at this one. So it says Jada receives a gift card of $300. Each week, she records the table how much money remained on her gift card. So at start, she has $300. After 1 week, she has 150. After 2 weeks, she has 75. After 3 weeks, she has $37.50. Okay, so she says that is an example, her spending is an example of exponential decay. Do you agree with that problem? Well, if you look at the numbers, they're going down. So I would say, yes, I agree. Yes, because for the explanation, the balance is decreasing. Okay, so now we want to write an equation that best represents the amount of gift money, G, in dollars that she has after W weeks. So this is our input number, the number of weeks. So in other words, where we would put X, we're going to put a W. And G, it represents the outcome or the balance which is normally what our y would show. So we're looking at an equation, g of w equals, okay, so remember, we have our initial value first. That was $300, so we're going to put a 300 here, times, now we need to put, I'm not going to put a decimal, I'm going to put or a dot for multiply. I'm going to put parentheses. Usually with decay, since you have decimals or fractions, parentheses are going to be easier to work. And we're going to put a W up here for the exponent for the number of weeks. Okay, so let's look at this. We have 150, and its previous value, not 500, it's 300. I'm sorry. Previous value is 300. So if we reduce this to its lowest terms, we get a 1/2. Okay, if we do 75 divided by 150, the number divided by its previous, again, we get a 1/2. And if we take 75 and divide it by, I'm sorry, the other way around, 3750 and divide it by 75, we also end up with 1/2. Okay, so the little calculator on the computer does not do fractions, so we'll just leave it at that. So our constant ratio here, or our decay factor, is 1/2. So that's our equation for the remaining balance on her gift card is 1/2. So we figured out the original amount, and we figured out the decay factor, what we're going to multiply by to get the next value. And W stands for the number of weeks. Now, in 1 week, she was at her half value, okay? And each time it went down by 1/2. Now, this, let's practice. This is your homework, okay? This is the other page that you have in the Google Classroom, and you're going to use this to answer the questions given the table. You're going to answer the questions about these two tasks, okay? One's on sea turtles and one's on an ant colony. So that's your homework for tonight. Now let's do a little summary and see if you guys understand. I'm going to give you, in class, I'll give you time to discuss this so you can kind of see what's going on. Again, this is kind of a summary question for those of you absent. You can put this on the back of your notes and just answer it. Write this down. If the rule for the medical marvel of medicine had been 500 instead of 400 milligrams to start with, how would the situation change? Now, the other day, we had a different initial value and rate of change, or constant ratio, the the growth factor, the multiplier. Okay, in this case, our multiplier is the same for both equations. So that part's not going to change. From one point to the next, it's still going to show 85%. What's changing is how much you're starting with. So that means that in this equation with the 500, our numbers are going to be larger each hour than the previous one. Okay, so we'd have more medicine each hour because we started with more. You have to excuse my handwriting here. Um, if I touch the screen, it makes a mess, so trying to write without touching the screen. Okay, so more medicine each hour because we started with more. So since the initial value is bigger than the original initial value, we're going to end up with more each hour, and it's going to take longer to decrease out of the body. Okay, so that is your um, lesson for today.